Cool. In an n by n grid representing a field of cherries, each cell is one of three possible integers. 0, which you can pass through. 1 means the cell contains a cherry that you can pick up and pass through. Or -1 means the cell contains a thorn that blocks your way. Your task is to collect maximum number of cherries possible by the following rules below. Start at position 0, go to the other corner by moving right or down. After reaching the bottom, return to 0 and then move left by going left or up in the routed path. When passing through a path cell containing a cherry, you pick it up and the cell becomes an empty cell. Okay. If there are no routed paths, then no cherries can be collected. Okay. Seems like either dynamic programming or even BFS, breadth first search. How many states? Okay. So there is a 50 by 50 grid, and you could be at one of the 50 by 50 areas. So that's n square or 2500. I feel like I'm making some leaps here. Some of it is I feel like I've seen a variation of this in the past. I don't remember when. Okay, so basically, but I think you could reduce this problem a little bit in that because there's going to be a lot of states if you have to return and then change the state, and you have to keep track of which cherry you picked and stuff like this. How many cherries are there? It doesn't say. So that means it could be a lot of cherries. So I think you could actually run. I mean, and in this case, it is symmetric in that going from the beginning to the end is the same as going from the end to the beginning in terms of cherry pickup. So in this case, I would simplify this as instead of going from the top to the bottom right to the bottom right to the top, from the beginning to the end and then back to the beginning, you could think of it as two going twice from the beginning to the end, right? So that's the first optimization I would think. And I think in that case, you could run them in parallel. And I would say the reason why you could run them in parallel is because, you could just do that in general. But why you should is so that you could keep track of cherries more, so that if you somehow are in the same spot, if you're in the same spot, then you only pick up the cherry once. So then you have this. So your states in this case would be x sub 1, y sub 1, and then x sub 2, y sub 2, right? And then, yeah, so, yeah. And if they're the same, and then you can pick up cherries when you're there, there's the only edge cases if they're the same. If the first coordinate is you go to the second trip's coordinate at the same time, then you only pick up this way. You don't pick up the cherry more than once is what I'm trying to do here. And if they're both in the same place at the same time, and you only count that cherry once, that's why I have this. And I think now that I think of it that way, because this is obviously n to the 4th, which is, I'm just using a calculator for a second, which is 6.2 million, which is, still iffy, especially since for each of these, how many transitional states are there? Well, I guess there are only 4, right? Because the left one can go down or right, and so is the right one. So that's just 2 times 2, so that's 4. But that's like 24 million operations. I think the other thing to note is that given time, for some time steps, so let's say you have a parameter t is equal to time, then the coordinate is going to be x1 t minus x1, because if because you're forced to move every turn. I guess you're not forced to, but you should anyway, to kind of, it'll help us to keep track. I mean, I think you're kind of forced to, but I mean, there's no time constraint, so I guess it essentially is the same. But forcing them walk each way will allow us to rewrite the first corner this way, because yeah, if you yeah, because for example, you start with 0, 0, and then the second one is going to be either 1, 0 or 0, 1, which the sum is 1. You could tell, and then you're going to add 1 every time, right? To either the x coordinate or the y coordinate. So x plus y is always going to be t. And the reason why this is important is because that allows to create the second thing in a similar way, right? Yeah. And because of this, now your states will just be these, which is now n cube, still 4 times n cube, but yeah, I think that should be enough. So if that's 50 to the third times 4, which is 500,000 to half a mil. So that's way faster, obviously 50 times faster. And then I think that's it. It's just breadth first search and keeping track of stuff. Am I good? Sorry, I'm just right now I'm just thinking of anything I'm missing. No, I mean, I think I'm good. So let's go. Okay. So now you have a queue. We need to use name tuples. Like, wait, okay, let's try. Maybe this is the time to do it. Oops. Something like this. It's been a while. All right. Oh, this is not even right. Well, I mean, it's right for x, y, but we actually want to do all the thing that we just said we were going to do, which is, we're just going to pair, even though it's more like 2. Okay. I think still, right? Okay. Let's declare some variables, and it's going to, can this be 0? No. Okay. M is 0 then equal 0. Okay. I guess they could be the same, which is maybe fine. Not -1, that's fair, but can they start on a cherry? I guess they could start on a cherry. Do I pop the cherry on the queuing or on the dequeuing? I guess on the queuing. Okay. I'm just going to write best in a hash table. Cool. He goes greater than 0. Whether this is a cherry or not. Okay. Okay. On top is equal to q dot partner. Just is it push right? It should be a plan. Oh, where is name? Is it tuple or tuples? Do it. Well, oh, it's not an array. Whoops. I mean, I think you could do an array, but I have a wrong syntax on it. I think that's just convention. I don't know. Oh, well, I guess it's right. Good call though, because I changed something, but not sure. Not very good on Python, I guess. It's been a while. Well, I've always. I mean, I haven't. I never played along with it, so okay. But it's a good point though. Okay. I guess I need a point one actually, just to make my. I think there's actually even like symmetric stuff that you can make it faster, like making sure that x1 is bigger than x2 or something, or the other way around. But is this by first search? Maybe I could just do this with dynamic programming actually, now that I think about it. Yeah, okay, I'm going to do it with dynamic programming. Yeah, okay. Use the rule. I guess it's just m plus n is the other one. So in m plus m, n plus m, you'll always get to the bottom. Okay. Well, I'll just make sure I don't have it out of bounds. It should be okay. Okay. And now for actually, no, I need it. Okay. Do I? No, I think one thing right now, what I'm doing now is thinking whether I need a three-dimensional matrix or a two-dimensional matrix. Um, but maybe I'll just do a three-dimensional one and then take it out later. Cool. So it takes m plus n times to get there. And then x, yes, x is say down. Then now you have the two-directional each. Okay. Now you have the transitions are t of x2 is equal to the max of t minus 1, max of itself at least. Start with that. Well, t minus 1, x1, x2. Trying to also figure out when to count the cherries, but cherry here is equal to grid nope, that's not right, obviously. Something like that. That to factor in the impassable stuff. Okay, let's do if grid -1 or continue. Otherwise, the cherry is just the sum of these, unless they're in the same price. Then you just take one. Okay. So this is if the y's something like that, maybe. Let's see if this crashes first. Okay. Oh yeah, I forgot to check for that. Wait, what? That shouldn't go out of track. Well, this could, but because I don't check for bounds, I forgot. But this shouldn't, right? This T is. Oh, right. That's not right. Like T minus N or N minus T or something like that. Oh, it should be just T. Because it can't go farther than that, right? And do I want it to be T? Yes, I do. Okay. Was it outbound side? So three. Oh, because T is. Oh yeah, I mean I just don't check bounds. That's why. Because there's no reason why this should be bigger than the other. But okay, I mean that's easy to do. If not, also learned this thing the other day. Let me see if it works. If X is on the M. I was confused the N and the M. I end up not using these. But is that an N or M? I always forget. It's gonna find me later. Yeah, I'll just use a non-web square array later. Or I would say dynamic program problem could often be modeled as a graph problem. In some in that like you could look at all these as like edges, right? And you're kind of going through that way. So there are a lot of similarities between them, and you could still do it in a graph way. But the way that I was doing it was not going to be BFS. I mean, it could actually still probably could be BFS in terms of time, but then you have to keep track of a few more things, and the states might be repeated a little bit. And that's what I was kind of worried a little bit about. Where dynamic programming forces me to kind of do it in one loop. But yeah, hopefully that answers your question. What am I doing? Okay. Oh man, so is my loop wrong then? Oh, this should be N. Bad programming. Yeah, okay. I mean, it's progress. Okay. I think it's also weird stuff where like this could be out of bounds, but yeah, let's fix that actually. Because this means it's y1 minus 1, right? So, okay. Could probably make this cleaner a bit. Also, I forget to add the cherry. I'll fix cherry. Missing a case. Okay. It should be mostly right though. Let me see if where I'm getting the error from. Um, hmm. Yeah, at least it doesn't take that long. Well, it doesn't take that short either, actually. But let me add some. Just to test my n's and m's. Might mix them up. Okay. Whoop. Okay, no, that was right then. Oops. I'm wary about this though. But can they both be out of bounds? I mean, no, next one should be already be here, so they. Unless t is weird. X1 and X2 should already be less than n, right? Yeah, okay, fine. Two. Okay, 2, 1, and 3, 0. That's fine. Oh, because this is dumb. Okay. Because both of these should be t. Which is m plus n because well, no, both should just be n, not yeah, because they're both x's on both axes. That's why. Okay, I mean, not crashing is progress. Okay. I think like we're also one of these things where we're just like a step away. Right? Maybe I'm off by one somewhere as well. Like n minus 1 plus m plus. This is minus 2, right? Because it takes n steps to go one direction and m steps to the other direction. But you start at 0. So 1 is 1, 0. Alright, let's do something more basic. Let's do a paradise of cherries, 2 by 2. Maybe I'm just returning the wrong index. Okay. At timestamp 2. So we're okay at 2. Timestamp 2. Let's take a look at t. Instead of guessing, t should be. Wait, this one. It should at least go to 3. 3 means 0 plus 3, but it also means 1 and 2, which is fine. Why did that get filtered out? So 1, 2 should be good coordinates. but this never goes to the end because of probably some kind of bound checking mistake. T needs one more step, or two more steps. Maybe three more steps. Because more that it's not even executing. Though this may be off by one, but it's gonna come point. Hey JJ9897, it's been a while. I mean, how long has that been? 30 minutes. Yeah, I agree with you. I get it in theory, but you know, in practice it's different. This also needs to be +1, but 3-0, 3-0, no good. 2-1, 2-1. Let's see, 0-0, and then go to 0-1, which is fine. It goes to 1-1. Maybe I'm just bad at math. And plus there's 2, so it goes from 0-0 to 1-1, which is true. I just have 1 off by 1. Is this just -2? Maybe it's something as simple as that. Okay, well, still not quite right. Wait, why did I output 3 things? Oh, what? Oh, why is that giving me a third answer? Or is that invalid input? That's weird. Maybe it's the printing. No, really, why is it why is it only giving me 2 answers and not the third one? Okay. Yeah, I mean, I'll explain it if I could get this right, but why is it not doing this one at all? Am I just like really bad? Like I return an output at least, even though it seems to be wrong. Does it have to be? Oh, it's n by n for. Oh, whoops! I actually missed that. So actually, I don't have to. Okay, so that's actually not a valid input. Okay. Once again, Larry's reading comprehension has failed him, but I put in this phrase specifically to test that, so that's okay. I mean, I think mine works for a rectangular grid anyway, though maybe not, because Quiddy did not give the right answer. Why doesn't mine work for... I'm curious why it doesn't work for it. Okay, I'm just going to submit and then see. Big money, big money. Ah. I pick up the cherry from invalid places, I think. I don't keep track of that. Or like I have to keep track of where I'm coming from as well. I think that's why. Okay. Because it seems like this is just because you're fenced off from something. Right? Because you're like diagonally fenced off and I still return something. Whoops. Okay. So if this is invalid, go. Okay. Right. I should have written this differently so that I don't have to do what I'm doing now. Oops. But it's too late. I've committed. Okay, maybe not. Let me uncommit. Okay. For oops, what the? Is this really cleaner? I don't know. At least I don't have to write it in order. Maybe it's cleaner. First one. The second one is. Okay, and these are the combinations. If they're within bound. Yes, actually, it can only be zeros. That's the cherry. Okay. Let's give it another whirl. I actually thought about this case earlier, but in trying to debug it, I forgot about it. Line 32. Int is not subscribable. What does that mean? Oh, what am I doing here? That's clearly not. Okay. Oh, sad. Oh, now I got even more answers wrong though. That's that's odd. Oh, okay. Well, that would do it. Hopefully that's. Oh, was hoping that was the reason why, but I think it's because I still I still do something with cherry. Cherry. Okay, so I think this is more right, but it's still wrong, which is unfortunate. Okay, let me put this somewhere and then stick deep into y and how we could jump over and get one. I guess that's the tricky thing with dynamic programming versus a breadth first search. In this case, it's because some unreachable states. Sometimes, if you're not careful, you could reach them by accident because you go for all the states. And in this case, oh, I see. In this case, it just if it sees a 0, it doesn't assume that. Okay, actually, I know what I have to do. So maybe now we'll just return -100, but that's fine. It's progress or negative something. Okay. Let me regression test for a quick second. That I can fix. It just means that it's not reachable, so the answer is 0, which is fine. Okay, so no regression test here. I'm going to choose a bigger thing. Bigger negative. What is n? I guess 50 is fine, but why not? YOLO. Big money, no whammy. Ah, really? I guess I needed to do buffer search, maybe. Huh. That's unfortunate. But this is only n cubed, unless I did something wrong with the math. Yeah, huh. It's only n cubed times 4, right? So it's 100 times... I guess n is actually now 100, so... But even 100 to the third is only 1,000,000 times 4, 4 million? Because I do... I mean, it should be fast enough, but... am I doing something silly? Can I make some linear app? I mean, this code is relatively tight. I guess I could do something like... Because the thing that's the thing with the buffer search that optimizes a little bit, is that the unreachable states don't cost you anything running time because you just don't reach them. In my case, yes, we kind of do. So I think this is off by 1, but that shouldn't change anything. Like it's only one more loop. Now I'm trying to figure out if there's a way to early terminate. I mean, there is a way, I guess, but it's kind of messy. Okay. What's my running time here? 48 milliseconds. I guess I could look at the case that gets it. Oh, it's literally what the on the does it give you the case that it tells you? So it doesn't tell you the case that the time limit exceeded on because you passed literally all of them. Because usually it tells you the last test that it doesn't pass or like that it failed on. So I guess I'm way close to the limit. So I guess I think if I did this in like C or C++, this is probably fast enough. But because I didn't, I mean, yeah, I mean, I think that's just poop. Okay, let me do. Okay, early terminate is equal to false. Early go true. Okay. If pass t, that means if we update it. Oh, this should be false actually. Okay. If early terminate, break. Okay. That will save us some loops. Is it fast enough? I don't know. Save shaved 4 milliseconds. I don't know how that consistent that is actually, but yeah, that's YOLO again. Yeah, I'll definitely go over the nuances. Sometimes it's just about how you feel, but oh yeah. Though that said, I probably should have done breath search and moving much slower, but much faster, because can't really complain when you're running that close into the end of the submission times. I mean, I'm not even on the graph. That's how slow it is. So, okay, got it. I mean, I think that you could. I probably could have done it with the way I was doing actually. I mean, and the code is very similar. Probably could have changed this to that too, if I have to. Um, but the reason why was I worry about having visit the same state more than once, and then updating the best for that. But I think actually, because of the strict ordering of imposed by this T thing, it probably wouldn't come up. But I wasn't. I wanted to save time not proving in terms of like coding time, but maybe that was a mistake because it cost me 5 minutes. Like if this is a contest, it would have cost me 4 minutes of fixing this, and also 5 minutes for submission. So that it cost me 10 minutes, and I could have easily done whatever it takes on the queue part. Um, I should anyway. So this ended up taking about just short of 50 minutes. So wow, huh? I mean that sounds like a long time for something that I knew what to do from the beginning. So I guess I'll have to watch the tapes to see where my time went. I mean, I know I have a couple of silly mistakes, and I end up wasting 4 minutes here, and oh, I didn't take account of reachable state, so that added at least 12 minutes. Um, but um, what line are you talking about? Sorry, n plus n. Oh, this. Well, one is apparently I think one is that it doesn't matter because it's guaranteed to be n times n, so the n and the m doesn't really like it doesn't really matter. But t represents the time, right? So if you think about, for me, I don't know if you were here at the beginning. Do I have a thingy here? So I have the reduction from. So you can think about. Now here's how I thought about it. So the problem asks you to go from the beginning to the end once, and then from the end to the beginning back, right? So there's two tracks. I think one thing to make it easier for me to think about is instead of doing that, you could flip the second path to from the beginning to the end, right? So instead of going from beginning to the end and then the end to the beginning, you could go from the beginning to the end twice. So that kind of makes sense, right? I think that step is like it's symmetric, so it shouldn't matter either way. And then now, given that, and why do you want to do that? It's because it buys us this thing where now we have an end to the fourth algorithm because the thing that you have to, if you do it like sequentially, the thing you have to do is to keep track of what the first path, like what cherries the first path took, right? And that's really hard. Or like, there's a combinatorial, craziness there that and the reason how I know how to jump into this is it's just kind of, I think I've done a similar problem. I don't know how long ago. So that's kind of a reduction. So now you get this algorithm, and I think that algorithm is like, okay, you have two paths, you have x and y, you have coordinate 1 and coordinate 2 running in parallel, kind of, and going from the beginning to the end, right? So there is a special case where if your first path and the second path at the same time, you kind of think about it running parallel. If they're at the same place, then they're going to only pick up the cherry once. And I think I actually have some code here that checks for this. Yeah, right. If the two corners are the same, then you only pick up the cherry once instead of, the cherry twice, because in this place, yeah. So that because the second time you do it, you're not going to go into the same way, right? So if you look at that, if you think about it that way, then the algorithm is going to be n to the fourth, just because they're. I mean that's just the way I mean I think that part is position. So when you see your kind well, so let me explain it my way first, and then I could kind of maybe answer questions. I don't know because so you understand the n to the fourth way where you have two different paths and you just have two coordinates, right? And then notice that every step that you take on both path one or path two, and they happen at the same time, it's always going to be plus one to the x coordinate or plus one to the y coordinate, right? So then, if you just look at the first path, then you can actually express the y coordinate. You're going to express the y coordinate with the x coordinate, right? I mean, I think so. This part is where the t comes in, and because and then now going to the second path, because time moves at the same time. At least you can enforce it because I don't think there's actually a strict restriction. But then, um, then yeah, so then you could do the same thing with the second coordinate because it's the same time step that you're doing at like you literally running it in parallel, and then that reduces it to n cube. Is why the reason there, and it also enforces certain things like you could like if they're both at the same place, they're going to be in the same place at the same time, right? So that kind of is why I did it this way. Oops, what did I do? Yeah, so yeah, so on each time step, so now you have those two coordinates and a t that links them together. Now you can think about it as each time step, with two kind of branch or two paths on that, and that's kind of how I came into it. Though I guess now that because this is actually technically t cube, um, t is actually, as you point out, n plus 2n. So this it makes the n cube a little bit bigger than the. I mean, it's O of n cube, but but yeah. And one thing that I could have done actually, which I haven't, which I didn't, is actually enforce that x2. I think this would actually save a lot of time, though I don't. Yeah, I mean that's the other So early termination is one. Oops, what did I? One way to kind of shave some constant time, but the other one is noticing that x2 can only be actually from x1 to t minus 1. I mean, because and that just explores the symmetry, if that makes sense, which I didn't do in my first submit, obviously, and that should half the time. And the reason why this is the case is because, yeah, I mean, you just swap. Like you could think of it if you have two parallel paths. There's one a path on the left and one on the right, and if and you could swap them such that swap your variables such that like the left one is always on the left. So that's kind of the reason behind that. Like actually, wonder if there's a big case I could kind of just see without submitting. Well, this is well for small ends it probably doesn't come out that much, but it's because I pass everything. It doesn't give me the big case. um, but let me see actually, see if that how much that helps. I mean, it still gives me the test case, but let me see how much faster it is if. How did I just do? Okay, let me actually just. 10, 20, 40, 50. Okay. Let me just do this exercise real quick. Okay. So this is probably the worst case. Um, Oops. Well, maybe not. I don't know if I counted right, so that's a little sad. What's 43? So maybe N and M is not the same or something. Shouldn't get a hard bounds exception. I don't have really anything hard coded. Let me try again. Dang it. Should write a generator for it. Okay, yeah, so that takes 308 and still gives me the right answer. And if I had my old code, I suspect that it would be a bit longer. 308. Yeah, so okay, so I would have saved a good amount of time if I had that optimization, which I think I talked about this earlier, but I just forgot by the time I submit because I was spending so much time on coding, and that's kind of one of the dangers of the like everything compounds on itself. I think is the problem. Let me oh, hey, the worst tanker ever. Let me Okay, let me speak to that in a second. Let me finish talking about this problem, which should be in a couple of minutes. But yeah, uh, but yeah, for this problem, I think I think someone else already mentioned that if you're in an interview, you're probably not going to be in a happy state. And I think I would point out this algorithm. I would maybe do the breadth first search one, or yeah, queue-based breadth first search or dice tree, depending on how you want to. But but otherwise, it's not that bad. Conceptually, to explain to someone if you have gotten it, I don't know. It's way too hard for an interview problem, if you ask me. It is a fun problem. It's way too hard for an interview problem. I think if you do get in this interview problem, yeah, maybe just ask to go to the bathroom so you could cry by yourself. But that's what I would do anyway. But I mean, at some point, I think my model here is that like there are, or if there's some problems that are so hard that then it is what it is. Where like, what are you gonna do if you're given this problem because they just don't like you or something? I don't know, because this is not reasonable in a problem. Like if they want to because there are things that you could test in this problem that you could test with a much easier problem. Right, the concept is simple enough. So in theory, like what I always test on when I'm an interviewer is around like the fundamentals, which is like dynamic programming or maybe breadth first search. And in those cases, I could ask a problem that are relating to them, maybe even in interesting ways, but not necessarily like impossibly like tricky to implement ways, right? But I think because this takes like there's no hints here, but this takes like and you walk. You listen to me walk through it a little bit. It takes like 3 or 4 insights to kind of even get there, right? So I don't think that's reasonable for for like even a 45-minute interview to have like all those insights. But well, oh my god. I think I don't know. Is there a tag on this? Well, this is locked, so maybe someone could tell me. I don't think that's legitimate, right? But really, eh, well, I don't know. That interviewer from Uber was having a bad day, and or maybe just thought it was something cute and want to give it. But I think I think part of an interview as an interviewer when I do interviews is that I do you have to do calibrations on your interview problems, right? And that means sometimes you will ask something that's way too tough, and it will take a couple of times asking that problems before you maybe realize it. But still, but that doesn't make it a good problem. It just means that in a sad way, sometimes you're a little bit of a guinea pig. But I mean, I think for me, like I have done enough interviews to kind of have a good sense of the difficulty I want it to be, and not necessarily to be cute. I mean, I think at the end of the day, especially nowadays, I feel like there's no such thing as never seeing like if your criteria for a prompt you're interviewing is like a prompt that the interviewee has not seen before, like that's not a reasonable expectation anymore. I don't think. I mean, I think like in the past, maybe say 10 years ago, you're like, oh, you've seen this prompt, let's do another one. Yeah, okay, but like nowadays, like you've like people practice to the point where like they've seen almost everything, and the only thing that's new is like some ridiculous craziness, and that's not a reasonable standard anyway. I mean, maybe there's something. Yeah, maybe people need to change the interview process, but I don't think that's or like in terms of structure, but I don't think that's it is what it is. Um, I mean, no, I mean, I think just to play a little devil's advocate, if you were in like some kind of like Uber self-driving car and you need like machine learning or some kind of machine vision type thing, uh, then you would write something like because there be a lot of stuff like you ask something around like machine learning and you ask like a machine learning related prompt. It doesn't like you don't need harder basic like harder fundamental prompts. You need like something more specific, right? Like either your machine learning background or maybe some kind of machine visualization. Whether that's like maybe explain some stuff about like fast Fourier transform or something like that, right? Where or like something that's like really specific, really you know, deep into what you're learning, but not necessarily like this. Like this, I like it's cute, it's fun, but like I don't know, yeah, uh, and and yeah, even and to your point, when I think actually like when you're a senior engineer, you actually I find that you actually get I wouldn't say easier, but you don't get like the difficulty like the album prompts, at least when actually, yeah, when I do interviews, I actually don't give different prompts for senior engineers and non-senior engineers that much, to be honest. I mean, there's some stuff to be said about like from familiarity with language and stuff, so we might grade you a little bit differently. But I give the same prompts because that's just the fundamentals, right? But that said, when you're more senior, you usually have different types of interviews, which uh, behavioral the behavioral interview means more, meaning that when you're more junior, your behavior maybe just like your attitude, your like how you want to learn and stuff like this. Where if you're more senior, it depends on like maybe more conflict resolution or how do you lead a team, and so you get more behavioral problems that way. And then the system design is definitely depending on the company. I think they either don't get ask you system design or very basic like OOP based system design, versus when you're senior, it's about like scalability system and how you scale like infrastructure and like how do you lay different components and what are the responsibilities of different components. So those things will determine your level more than the algorithm part, in my experience. And obviously, it's not always going to be every company because some companies just do things differently. So I can't speak for all of them, but that's how I've seen them structured. Um, yeah, and definitely. Well, also welcome RT, but yeah, I've definitely seen. Um, Yeah, I mean, I've definitely had this in the past, which I haven't had recently, to be honest, where the interviewer would give you an MP complete problem, and then kind of like almost just to see what your process is like, because they know that is an impossible problem, so they would want to see like the thought process on how to go through it. Um, so that's definitely a thing. So I would definitely and not necessarily like let you programming, but but yeah, hey, Postman. I mean, I thought it was okay. I mean, I spent a lot of time explaining this one, and we're still explaining this one, and slash some stuff about just interviewing in general. I think I'm mostly done about talking about this problem. Mostly, we're just talking about how hard this problem is and how maybe it doesn't come up on interviews as a result. Though apparently, Uber has asked this in the past, which is kind of sad. But yeah, I mean, process definitely should matter and just like how to think about things. But yeah, in terms of leveling though, I mean, definitely process does help a little bit as you get more experience and seeing more problems and so forth. But leveling definitely also relates to the non-coding portion as well. Um, like they rate way much more, to be honest. Yeah, and I think that's what I'm gonna say about that one. Am I done? I think I'm done. um, I think so. I mean, you could do this in breadth first search, and there's early termination. Uh, but that's essentially right, I think, because that's the number of states you have, even when you do a breadth first search. So I think that's gonna be right. Um, can you do something in n square? I don't think so. I could be wrong. But yeah, definitely let me know. I mean, and well, one thing I would say is that okay, so this is n cube time, but you can actually do this in n square space, which I didn't do. I was thinking about doing it, but it's already a hard enough problem, so I didn't want to think about it that much. And I end up using what was I forget what my percent. Oops, I forget what my percentage tile was for. Oh, is that for memory usage? Um, I guess I did okay on the memory part. I don't remember my percentile. If you know what it was, let me know. But you can actually um, reduce this to n square space, which actually, ironically, you cannot. In this case, if you do breadth first search, you actually need n cube space. Where in dynamic programming, you could actually get away with n square space because of how you. Maybe that's not true. Maybe you could do something clever with breadth first search, but actually, I think you can too, but it's a lot trickier. But yeah, there's a. Oh, really? Okay, cool. But yeah, the and I'll show you how to do the quadratic space. Is that if you look at this equation, which is the only thing that updates, yeah, you can notice that best of t is always based on best of t minus one. So you could kind of have basically two n square arrays, and then just kind of go back and forth on them or something like that. So that's the quadratic equation, and imagine that's what the solution will bring up. But that's, I mean, because that's how I would optimize my solution, if that makes sense. And that's a very common thing to do in dynamic programming is that you notice that you only use the last n, or not n, sorry, last k for some constants number of previous solutions, and then you just keep track of those. So then you don't have to keep track of all of t, right? Because if you look at here, we never care about anything before t minus one. Like t minus two, you can throw it away. So that's kind of the idea between that and then it's just more like maintaining the pointers and indices or whatever and so forth. And actually, I think the key way to do it is actually so you could do something. Does this actually tell you the memory when you want it? Let's see for a second. I guess it doesn't actually. Was hoping that would be. But you could get to work by. I think there's a clever way where, yeah. So if you have just like an array of two elements, you could do something like this even. And in this case, it's like technically. So something like that. And that would give you the answer, I think. Though there's some weirdness with kind of initializing and stuff like that, and kind of cleaning the memory for use. So you do pay penalties there, but in theory, it's not. And then in this case, obviously, you would just have an array of index two. So instead of so this is the t, so then you just have two, and then this should, in theory, work. This would not work because I have to like go for a for loop to initiate, but it shouldn't crash. Is what I mean, right? So that's kind of this actually ended up working by accident, I think. But but yeah, but that's how you would actually change it to all of n square space, and I did. That was actually easier than I thought. So maybe I should have done it to begin with. Let me see. I think this should give me the wrong answer because I don't think I reinitialize anything. Okay, maybe I get lucky again. But my point is still that this, but that's roughly how you would, oh, did it? But that's how roughly I would, yeah, because you don't have to go through as much memory, maybe. I don't know. But but that's how you would generally do it. I think this is still wrong though, to be honest, because I don't clean the memory, if you will, like initialize everything to zeros or in this case negative infinities. Um, but yeah,